Okay, let's take a look at the cosine law. Now, we can use the cosine law with any triangle. And it's going to help us because sometimes I don't have a right angle triangle where I'm able to use the Pythagorean theorem or my sine, cosine, tangent ratios. Okay, we looked at last time the sine law, and again, I can use that with any triangle, no matter if it has a right angle or not. So if I look at this triangle down below, no right angle, so automatically I cannot use the Pythagorean theorem or sine, cosine, or tangent ratios. Now if I try and use the sine law, I can try and set it up. So I have the sine of 70 degrees, and I want to find side Q, that's opposite to my angle. Now I run into a problem with my other two fractions because sure, I have two side lengths, 17.5, but I don't have angles to put in for sine. I don't have angle R, I don't have angle S, okay, which doesn't help me, and I have no way of finding them. So here, we can't find Q with all of the things I currently have in my toolbox. I have to look at something else, which is where the cosine law comes in. Okay, so just like the sine law can be used for any triangle, there is something called the cosine law that also can be used for any triangle. And there's two different formats which you are given on your formula sheet, and they are in this box down below. Okay, so if I'm going to determine a side length, the formula is a squared is equal to b squared plus c squared, very similar to Pythagorean theorem, minus 2bc times the cosine of a. Now what you're going to notice, it seems like a lot to remember, but keep in mind you don't have to memorize a thing. The only thing you have to know how to do is use this formula. Now if I'm solving for a side length, that's side length a, it's always going to match the angle that you're going to use with cosine, and it's going to be its opposite angle to that side length. All of the other things, like BC, it doesn't matter what order you put them in. It doesn't matter at all. The only things you have to keep in mind are the side length and the angle that you're trying to find. Okay, if you're determining angle measures, basically it's the exact same formula, just rearranged in a format that's solved for the angle. And just like before, cosine of A, cosine of an angle, and this A are a side angle pair. So if I'm using the cosine of A, little a squared is the side length that's opposite to it. Okay, we're going to do a bunch of examples, and hopefully they help illustrate this point. So in the very first example, we are asked to determine the length of the missing side to the nearest tenth. So what I'm trying to find is x in this case, the missing side of that triangle. Now we had a formula for determining side lengths, and it told me a squared is equal to b squared plus c squared minus 2bc cos a. So we're going to go ahead and fill in this formula with all of the information that we have. So I want to figure out what side x is. So it's going to be x squared. Now b and c are going to be the numerical side lengths that I have in the question. It doesn't matter what order you put them in. I'm just going to choose to put 5 first, so 5 squared plus 8 squared minus 2 times 5 times 8, and then cosine, the angle has to be the one that's opposite to the side length we're finding. So if I'm going to solve for side length x, its opposite angle is 50 degrees. So I have to use the cosine of 50. Okay, I'm just going to throw the right hand side into my calculator and get a decimal here. So give me a second. 8 cos 50. Okay, so as a decimal, making sure your calculator is still in degree mode for this, 37.576999123. Now in order to figure out what that side length actually is, you're going to have to square root both sides. Just square root that long decimal we just wrote down, and to the nearest tenth, x works out to be 6.1 meters. Okay, so there's an example of how I can use the cosine law to help me out. We're going to do B as well, and I believe down below we look at finding angles. So part B also asks to find the missing side length. Again, let's call it x. We can set up our cosine formula, our cosine law, just how we did before. Copy, paste, and I'm forgetting a square. Squared. Okay, so in this example, it's still x squared. B and C come from my other two side lengths that I actually have numbers for, so 21.6 squared plus 8.7 squared minus 2, 21.6 times 8.7, and I've run out of room. And lastly, cosine of the angle opposite to the side we're solving for. So I'm solving for side x, its opposite angle, 30 degrees. Okay, so 21.6 squared plus 8.7 squared minus 2 times 21.6. Multiply that by 8.7, cosine 30, and x squared turns out to be 216.7630122. If you square root both sides to the nearest tenth, x turns out to be 14.7 centimeters. Okay, so not terribly difficult. The formula just is long, and as long as we put things in the right place, we're able to use that formula to solve for what we want. Okay, so there's how I could use it to find a missing side. Down below, determine an angle. So this time I have all three sides, and I'm trying to find the missing angle. So here's what my formula looks like. Cosine of my angle that I want to find is equal to b squared plus c squared minus a squared over 2bc. Okay, and that formula will be given to you, so no need to worry about a thing. Put in everything we know. Cosine of x is what I want to find. B squared and c squared are the two sides that are not opposite my angle. So in this case, that means it's 5 and 6 minus 7 squared, because 7 is the one that's opposite to the angle I want to find. So let's just make sure we color code those for now until we get used to this. And on the bottom, 2 times 5 times 6. Okay, if you put all of that in to your calculator, you're going to get a decimal, but then we have to figure out how to solve for it using cosine. So 25 plus 36 minus 49 divided by 2 times 5 times 6. So the cosine of x is 0.2. Now, in order to get rid of cosine, we talked about using the inverse of cosine, which is on our calculators. And it looks like this. Cosine to the power of minus 1. Put my decimal in my brackets. 0.2. And to the nearest whole number, that angle turns out to be 78 degrees. Okay, 78 degrees is what we get for that first one. Second one works much the same way. Cosine of x is equal to the square of the two sides that are not across from my angle. In this case, that's 12.3 squared plus 15.2 squared. Now I have to minus the side that's across from my angle and square it. Divide by 2, 12.3, 15.2. Okay, and then we can find out what cosine of x should be equal to. So 12.3 squared plus 15.2 squared minus 7.6 squared. And 2 times 12.3 is 15.2. Okay, so cosine of x is 0.8680198973. So x is going to be equal to the cosine inverse, so cosine minus 1, of this long decimal that we got from our previous step. Okay, so if all of that goes into your calculator, again, please make sure that it is in degree mode. To the nearest whole number, x is 30 degrees. Okay, so there's how we could use the cosine law to help us find a missing side length or a missing angle. Okay, and here are some of your key ideas: Pythagorean theorem, SOHCAHTOA, sine law, cosine law. Okay, again, for those of you without this booklet or are watching this and you don't actually go to Lizzie and Osborne, here are some practice problems that you can try out on your own. Hold it there for a second just so you can pause it. And the answers will be down below. Okay, so there are your answers to those practice problems. And I hope this helps, and we'll see you next time.